Alright, so we're going to be talking about how to target with Crosshair. The idea is to go all the way from the very beginning to the very end and really go through step by step. So we're going to start off talking a little bit about the system, how it works, how you set it up, and then we'll go through the actual workflow. So this is the system. It runs on top of a normal Leica EM UC7. There is one modification to the actual microtome itself, which is this hole here. You can ignore these ones to the side. This is the hole that we need. And this is because our arc piece has a pin in the back which can go into that hole and hold it vertical. That is very important for the workflow. So if you want to use it on your microtome, you will have to drill this hole so that it is in the vertical position in the arm. That is the one change to the actual microtome itself. Everything else is an add-on, so you can just put it on top of a normal Leica EM UC7. So the pieces of that, we have this box off to the right that has the computer inside that actually controls all of the motors. So the wires come out of here and then go into each of these motors. There's two on the arc, one for the tilt and one for the rotation, and one on the knife to control that rotation. Something to note is that this only controls these motors, so it only controls the rotation of those axes. All of the cutting and stage movements and all of that sort of thing is done via the normal Leica controller. So you have to do a hybrid thing of doing it a bit on both of these. Okay, so let's zoom in a bit and just see it working. So you can see here the knife moving under the motor. So the advantage is you can go very precisely to a particular angle, and you can very precisely read off your current angle on that box that I showed off to the right, and you'll see that in a minute too. So just so you can see what it looks like, this is the same for the rotation with the motors, and the same for the tilt. So that is the system. This is the user interface. So it's a touch screen, you just touch on it to control it. The left panel controls enabling and disabling the motors, and I'll show you in a minute why that's actually useful. This button controls setting the 0 for that particular axis. This is where you enter in your actual angles. So you type in the angle you want to go to, you click enter to go to that value. Go to 0 then goes back to the 0 value. This panel gives you readouts of the current rotations of each of your axes. So this is for the knife, and then this is the rotation and the tilt. The right panel is more technical details that we don't really need to go into right now. So this panel here is all for the knife. You can see that up here. But there's one panel for each axis, so you just got to make sure you're on the right one. Okay, so let's see that in action now. So here you go in, you type in what angle you want to go to, you click enter, and then the motors will drive you to that position. If you want to go back to 0, you click on go to 0, and it goes back. So this is all quite straightforward. You just type in your values and it will go there. So, like I said, this is the panel for the knife, but there's a panel for each one. If you want to change between them, you have to click on this little button up here, and then click on the axis that you want. And then you'll get the same page, same controls for that axis. Okay, now let's talk about the motors, enabling and disabling. Why would we want to do that? So, if you enable the motors, all of these are locked in, and you should only control it through this user interface by typing in the values. If you disable the motors, so you click on this button, these then become loose, and you can control them like you would normally. So you can rotate these dials, and that will move all of the different pieces as you would expect. The advantage of this is just to make it flexible. So there are some steps where you have to align the knife and the block face, and for someone who's been working at a microtome for a long time, it's a lot easier to just do that by disabling the motors and going manually, and then enabling it all again when you actually need those functions. Okay, so that is the system. So now we can go into the workflow itself. This is the workflow. This is more for reference, so don't worry about understanding all of this right now. We're going to go through it step by step. So we're going to start up in the top left and then work our way through this diagram. So first of all, we need to trim the sample with the microtome. So some things to bear in mind here. You need to make it small enough for optimal resolution in your micro CT. This depends on what kind of system you have. So in some systems you have to trim it smaller in order to get close enough to get the best resolution. Some other systems don't need that, so do what's required for your particular micro CT. Then you need to trim a flat face into the top of your block. And this has to have a particular shape. It has to have 4 corners with straight lines in between. I'll show you some examples of that now. So this is an example block. This here is a little marine worm that we're going to be using as our example sample. And then the rest of it is our resin block. And what we've done is with a diamond knife, we've trimmed this flat face into the top. That's what I'm referring to here. When I say it has to have a particular shape, I mean that if you imagine looking down on this block from the top, a shape like this would be good for this workflow. So you've got 4 corners with straight lines in between. But equally, this would also be fine, or something like this. It's just anything with 4 corners with straight lines between those corners, that is good. You've got to make sure that this is done very precisely though. So do use a diamond knife to trim this flat top surface, but then do go around the sides to actually get these edges very crisp and straight rather than doing it with a razor blade. That will give you the best accuracy. Okay, final thing to bear in mind is make sure that you cut deep enough to ensure that you hit that face first. What I mean by that is you've just gone to the trouble of cutting this really nice face with your diamond knife. But below that, you've probably just trimmed with a razor. So that's what I did here. This is just trimmed with a razor, and only this top bit is done with a diamond knife. And that was just to save time. What you got to make sure is that if you were going to cut this and you had like a knife angle that was maybe a bit more extreme, you need to make sure you hit this face first and don't hit the rest of your block. So if I hadn't trimmed this down so much and I had this little square and then it went wider with like the rest of the resin block, then if I was cutting at some angle, it's quite likely that I would hit the rest of the block before I hit this little square. So you've just got to bear that in mind. Depending on where you're trying to get to and this sort of thing, make sure that you've trimmed it away so that you're going to hit that face you made first. Okay, this is this. Also, just to make the point, this you can do with any microtome. It's just normal trimming as you normally would. You don't need to do anything with the motors or anything like this. Okay, so once you have your sample trimmed, it's looking good, we can go and micro CT it. So here's this example we had, and then this is an example of the reconstruction. So here's our worm, and here is our block. So for this, you just follow the instructions for your particular micro CT manufacturer, whichever one you have. Some things to bear in mind: do it at as high a resolution as you possibly can. We can usually get around 1 micron. This is what will limit your accuracy. So the higher you can go, the better your accuracy is going to be. The other thing to bear in mind, make sure you get all of your sample in the frame and also all of this top face. I need that for the workflow, so make sure you include it in the x-ray and you don't crop it out. All right, so at this stage, we need to swap over to the Crosshair software and set up all the planes and points. So this link I've put here is the link to where all the installation instructions are and all of this. It's a Fiji ImageJ plugin, so you'll also need to have ImageJ downloaded, but all of the instructions for that are there. So I'm not going to go through that now. I'm just going to go through the particular bits you need to do for targeting this sample. So the first step to all of this is to ensure that your data is flipped correctly. So what I mean by that is that when you open it in Crosshair, you'll see this 3D view. You'll have this little 3D representation of your block, where you'll see your block and you'll see your sample inside. What you need to do is you need to look at that 3D view and compare it to your actual sample and see, do they look the same, or does this look like a mirror image of your sample? And this will depend on what file format you had, what particular CT, and how it was processed before, all of these things. So really do take your sample and compare to this 3D and decide, okay, does it look the same or does it look mirrored? If it looks mirrored, you will have to flip your data to correct for it. So take your images into something like ImageJ and in ImageJ you do image, transform, flip vertically. And now when you load it in, your 3D view should look the same. So just make sure you do this first, check everything looks good. Okay, and with that, you can then actually go into the software. So again, I'm not going to go through all of the details here because there's a whole bunch of instructions on that website that I just showed. Just for the basics though, this middle one is a 2D view, so you can see all your different X-ray slices. This is a 3D view, and then all of your controls here are on the left. So, first of all, I'm just going to kind of scroll through, see what it looks like, and then I'm going to set up my target plane. So what I did there is I clicked on track, and what that does is it means that wherever I am in my 2D view, it will show me that in the 3D view as a plane. So this green plane is where I am right now, and as I move, it will follow it. So what I'm doing is I'm just moving my 2D around until I find my target. So I want to cut through these little blobs that come out the side of the worm, and I'm checking it in the 3D, and I'm checking it looks good. So at that point, I've set up my target plane. This is where I want to go to in the orientation I want. You would put it wherever you're trying to go to in your sample. Okay, the second plane we need to set up is the block face, and that is on this surface, this bit that we trimmed before that I was talking about. So, to do this, I move the view around until I can see a nice cross section through the block. I've clicked track here just so I can see where that plane is and set up a nice cross section through the block so that I can see the surface well. So here I'm just kind of moving it around a bit and trying to get a good setup. Again, this is kind of up to you, but this is how I like to set it up. Okay, so at this point I've got like a nice cross section. I'm quite happy with that. I can see my block face here, but it's a little bit dark. So if your data is a little bit dark, you can adjust the contrast, which is what I'm going to do in a minute. So you go here to this blob, you click on your raw, and then you can decrease this slider to increase your contrast a bit. Okay, so now it looks good. Then what you do is you right click, and I'm going to get there in a minute, toggle the point mode, and then you can just click on the surface to give points. So every time you click, it's going to give you this little green blob, and that will also appear over here on the 3D. And then what you want to do is you just want to scroll through and place points all over this surface. This takes a while, so I'm going to skip ahead. Okay, so now I'm happy. I have a whole bunch of points. It's looking good. So I toggle the point mode again, then I right click and I fit 2 points. And that gives me that plane that's aligned to that block surface. So these are the planes we need. This is then done. We have the block plane, which is the surface, and we have our target, which is where we want to go. Now we need to set up a whole bunch of points. So if I click go to, that'll take me to my block plane. And you see this nice square shape that I was talking about. You right click and you toggle the vertex mode, and then you want to put 1 point on each of the corners. So try to be as precise as you can. So just click and add them in. Again, I take a little while debating exactly where to put these, so I'm going to skip on a little bit as well. Okay, so once you're happy with it, you've put points on your 4 corners, then you toggle the vertex mode again. And now what you need to do is you need to decide which way up your block is going to go into the microchime. So you need to look at your 3D view and choose which face will be up. So for me, I tend to choose the side that the worm has sunk down against when I've been embedding it. So I'm going to use this as my top. And what you do is you click on the vertex and then you click on what it is, whether it's the top left, the top right, the bottom left, or the bottom right. So I've clicked on it, I click top left, I get the little words telling me what it is, and I get the little abbreviated version in the 3D view. So here it says TL. I'm just going to reduce the opacity a bit so you can see it. There you go, TL. And then you want to try and match them. So because I want this to be my top face, this is wrong. And this is something that's particular to Crosshair that you've got to think about. The issue is when you're looking in a free 2D view like this that can rotate anyway, you don't know which way you're looking at the block from. So I'm looking at this blue face, this blue plane, I know that, but I could be looking at it from this direction or from behind. So always, what I'm saying is always click on your points and assign them and then compare to your 3D. You want it to look good by your 3D. Okay, so now I'm going around, I'm correcting them, always clicking, and then comparing to the 3D. Top left, that looks good. So now I'm going around doing the top right, the bottom right, and the bottom left. Okay, so now it's set up. We have 2 planes, we have our 4 vertices, and I have my orientation. I know which side is going to be up. At that point, you would just click this button here to save your settings, and that will give you a text file, which you can then use to load at a later stage if you need to. Alright, so now it's set up. It's set up in Crosshair. The next part is to set the zeros for the knife and for the arc tilt. So you've got to go back to the microchime again for this bit. So we'll start with the arc tilt because this is the fast one. You just need to disable the motors and then go to 0 by eye. So that's what we're doing here. We're just turning the dial and trying to get this as close to 0 as possible. Okay, looks good. And then the next bit is to then set that 0 in the software. So you just got to make sure you're on the right page for the sample tilt. And then you go here and you click set 0 and you'll see that it goes to 0. Then that's it. That's it for the arc tilt. That's done. Now we do the same thing for the knife. So it starts in the same way. We disable the motors and we go to 0 by eye. So you just want to try and get this line here to be close to 0. For the knife, we've added some extra steps because, the knife comes in and out, it gets clamped into place and all of this sort of thing. We figured there might be some more inaccuracies there, so we wanted to have an extra step to try and be as accurate as possible. So these are those steps. At this point, you enable the motors and you want to cut into a blank block to make a vertical face. By blank block, I mean a block that's just resin. Like, there doesn't have to be anything in it. It can be any shape or size or anything that you want. It just needs to be able to be cut into to make a face that you can then align to. Okay, so here we are doing this. We have this blank block in here, and we just have our trimming diamond, and we're just cutting until we get a face. So you can hopefully see that here, this bottom here, that we have a little shiny face there that we can use for alignment. It doesn't need to be very big, so you don't have to cut super deep either. Okay, so once we have this face, we need to rotate by 90 degrees. So again, we do this through the interface. Make sure you're on the sample rotation. You type in your 90, you click enter, and you'll see it rotate over here. So just to see that in a little bit more detail, it just rotates 90 degrees. Whenever you're using the motors near the knife like this, always make sure you back the knife off because the motors move reasonably fast. You don't want to whack your block into the knife because that would be bad. Okay, so now we disable the motors and we want to align the knife to that face that you made. So you only want to adjust the knife angle here. We're just trying to realign and then that should be our new 0. Okay, and once you're happy with this, we just set the 0 in the software. This is the same as before, but make sure you're on the knife page and click the set 0 and then you are done. And then enable the motors again. Okay, so like this seems like a bit of a long-winded process, but really it's just you have a blank block that's just resin, you cut in to make a face, you rotate it 90 degrees, and you realign. That's it for doing this 0. Okay, so now we need to do the actual alignment with our sample. So we replace the blank block with our actual sample block. And this is what it looks like. So this is then looking down the microtome. Here's our block, here's our worm, and here is our knife. And you see it's very much not aligned at the moment. Then we want to disable the motors, and then we can freely adjust any axis just as we normally would to do this alignment. Couple of extra things to bear in mind though. You have to make sure your sample is the same way up as you decided in Crosshair. So the edge that you decided would be your top left, top right. That needs to be at the top. And you've got to make sure that the bottom edge of your block, so your bottom left, bottom right, this edge, is aligned along the edge of the knife. So by that I mean if this is your block and this is your knife, I mean this edge has to be aligned. So you want these two to be as parallel as possible. So those are the extra things. Apart from that, it's just a normal alignment. You go in and you do it manually as you normally would. Okay, so here we start doing the alignment. You see it's starting to look better. And here is our final alignment. Everything's looking very nice. Okay, so at this point, we then set our final 0. So the arc rotation 0 is then defined by this. So all you have to do is go to the rotation here, and again, just click the set 0, and you'll see that it goes down to 0. And then enable the motors again. Okay, so now all of our zeros are set. Everything is looking good. Now we need to enter the knife and arc tilt angle into Crosshair. So now we need to go back to our computer and enter these things here in. When I'm doing this, I often just have the laptop off to the side so I can quickly enter stuff in. Okay, so let's see that just in the program. So what I'm doing is I'm reading these values off of that box to the side that I showed before with the touchscreen on. So I'm reading off the knife angle and typing it in. Make sure you get the right sign. It's important. And then I'm doing it for the arc tilt. So again, I'm just entering in what it says on the box. So entering it in, and then we click this button here to go into microtome mode. This gives us this really simple 3D model. So this is then the knife, and this is the arc piece, and everything's in the orientation that it should have in the microtome. So it's just to help you visualize what's going on. Okay, and then we have to choose a solution. So we do that by sliding this last slider here. So there are a whole range of different solutions that are possible, and you just have to choose whichever one's best for you. So maybe you want a particular orientation for whatever reason, whatever you're going to do after this, or maybe you want to have a small knife angle, or etc. etc. It's up to you, whatever you want. So here I'm just browsing through. I'm looking at what the orientation would be and what that would look like. And then in the end, I just went for the one that has a solution rotation of 0, just for ease. So that's this one here. You can see at the bottom here all of the angles it's giving you and the distance you would need to cut. You can click this Save Solution button, and that will again give you a text file which has all of that information in, which you can save and then use again. Okay, so just to recap that bit, we read the angles off the touchscreen, we put them in the software, we chose a solution, and it's really any solution. So, you might want a small knife angle or a certain orientation, but it's really up to you which one you want to use. Okay, now we need to actually execute that solution. Just go and do it at the Microchime. So this is our text file that we get from the solution, from saving it. These top 2 lines are just for reference. These are the 2 angles that you entered in for the knife and the tilt. These are then your rotation values for the knife, the tilt, and the arc rotation. The first touch is predicting which point you should hit first when you start cutting, in this case the top right one. And then the distance to cut. So here it's 181.6 microns. So this is all the information we need. And the first point is to back the knife away. Again, when you're going to be using the motors, make sure that your knife is out of the way when you're going to do some rotations. And then we need to enter in these 3 angles for the knife, the tilt, and the rotation. So once you've done that, the motors have gone where they need to go. This is what it looked like for us down the Microchime. This is, again, the final knife position and the final arc position that we had. Then we need to actually cut. So we have to approach the block manually until we're as close as possible. So here what I tend to do is go until I've cut a tiny bit off of one of the corners. It's important to try to be as precise as possible here, because any error you have here, like you cut too far or you hadn't quite reached the corner yet, that will be an error that's in your final, your final targeting. Okay, so this is what it looked like when we started cutting. We've just started cutting this corner here. And this is a good time to check your first touch and check it corresponds. I predicted the top right, and that's exactly what we have here, so that's great. Okay, then we cut the specified distance, so that's this one here, 181.6 microns. We use the Leica controls. They have the countdown settings and various other ways to track your distance. Use whatever you like the most, and cut as close as possible to this. So here it is just starting cutting. And here it is when it's all finished. So here, this is our final target plane. We've cut through the head of this worm, and now it's ready to go on to whatever imaging we want to do. Okay, so that is it. At that point, you should have reached your target. Everything should be done. For more information on this and all the written tutorials, it's all at this website. Great.